Okay, so coming back to the classic implementation of chain of responsibility, I have to confess that I don't like it. And there are many reasons why I don't like it, but the biggest reason is that the actual handle method here in our bonuses implementations actually permanently modifies the creature. It permanently modifies the creature. It takes the creature and it modifies its state permanently. I don't want this. I don't think it's a good idea. I think that this prevents us from removing the modifiers later on. So let's suppose somebody removes or blocks or I don't know, cast a spell to remove the double attack modifier. What happens to the creature? And the answer is we have to recalculate the creature again by following the entire linked list. Now, I'm okay with this, but the way it's implemented is a bit ugly, because then you would have to somehow revert the goblin to its original state. And notice we're not storing the original state, we just have a single instance of goblin when we modify the goblin using modifiers. So it becomes painful. In addition, we have maybe too much exposure. We have to expose the actual basic attack and defense values for them to be modified. I don't want to give outside components right access to attack and defense, because attack and defense are typically defined at the beginning of the game. They're predefined, and then you can build bonuses on top of them. So I don't want this implementation. I think it's a classic Gang of Four implementation, but it's not great if you want the maximum flexibility. So we're going to rewrite everything completely, and we're going to use yet another design pattern. In addition to chain of responsibility, we're going to use the mediator design pattern. So the mediator is like an in-between component that everyone uses to get some information. And in our case, we're going to call this mediator game, because all of these goblins or other creatures, they participate in a computer game, and we want to have all of them refer to this game. It's very important for at least this particular implementation. So here's how it's going to go. The game is going to provide a query API for asking the attack or defense values of a particular creature. And the way this is done in .NET at least is using events. So I'm going to have a public event handler query, and query is going to be the query object. So the query is where you specify what you want, who you actually want it from, and then subsequently what happens is you also store the result of the query inside the query object as well. So we're going to have public event handler query, and we're going to hold this queries. There we go. So I'm going to define a class called query, and it's going to be a class where you specify what exactly you want. So for example, we need to specify which creature we want information about, so we can have public string creature name, for example. We can also specify what kind of argument we want to find out. Do we want the attack value? Do we want the defense value? So for this, I'll make an enum. I'll call it argument, like so. And we're going to have either attack or defense. So this is the argument, and then of course you need an instance of it, so we have public argument what to query. So we specify what kind of information we want from a creature, and then of course we want the query itself to store the value that's being queried, so we'll have public int value. Once again, I'm using public fields here. It's not an indication of how to program, but I'm just trying to save some time. Okay, so what we're going to do now is we're going to make a constructor. Let's make a constructor which initializes all of these, because we need all of them for actual querying. Now you're probably wondering, why do we need the initial value? Why do we need to pass in the value? And the reason is that if we have a bonus, we have a bonus on top of the initial value. So this is the value that you pass in. So if you have an attack value of 2 and a bonus of +2, you pass in the 2 here, and then the event gets invoked, and somebody gets to add another +2 on top of this. So somebody takes the value here and adds an additional 2, and that's what gets returned. So very convenient approach. Now, having made the query, we might also want to add an API inside game for actually firing those queries. So that's fairly obvious. So I'm going to make a method called perform query. So we're going to make a query, and here you have to specify the sender and the query itself, and you simply take the event. So you say queries ? dot, and you invoke, passing the sender as well as the query. So that's all that we have to do here. Okay, so now we have a query API, and the question is, well, how can a creature support this API? And this is rather easy as well. So let's make a creature, and it's similar to what we had before in a way. So, but in addition, we also now take a reference to the game. So we have private game. So this is our mediator object. In addition, we have, I'm going to make a public string name. So here I'm keeping the name public because I'm going to need it later on, but it's not critical. You can make it private and make accesses, whatever. And then I'll have private int attack and defense values. Notice these are private. You cannot really modify them because we assume that the creature's attack and defense values are fundamental to that creature and they cannot be modified. You can make bonuses and adjustments to those values, but you cannot define or change the fundamental values. So now let's make a constructor. We need a constructor for pretty much everything here. So short circuit some of these. Whoops, what did I just do? Let's try this again. So join in file. There we go. Okay, so having made this, we now want to actually let people access the creature's attack and defense values. So the way this is done, obviously we don't want people to write to those values, but we do want people to read those values. So we make a property. We say public int attack, and we make a getter. Now the getter needs to collect all the bonuses. So the question is, well, how do you collect all the bonuses? But luckily we have a mediator called game, and this mediator can be used. So we make a query. We say, oh, I'm going to query the creature name, which is name in this case, and that should be just ordinary name. Actually, I should just use an ordinary constructor here. Okay, so query. Let's take a look at the documentation here, hopefully. Let's take a look at this. Okay, so creature name, it comes first. We have to specify the name of the creature we're trying to get information about. We're querying its attack value, and the default value, the baseline value, is attack. So that's our query. And then what we do is we invoke it on the game. So we say game.perform query, and we specify the sender as this, even though in our scenario we're not using this particular argument, but it doesn't really matter. And we specify the query. So at the end of this query, we have q.value, which contains the actual attack value, and that's what we return. We return q.value. There we go. Now we can perform a similar operation on defense. So I'm just going to duplicate this, and we'll have defense, and you simply specify defense here. So that's the accessors for the attack and the defense. Let's also implement some sort of toString. So I'm going to go into formatting members. Now what I want to output is the name as well as the properties for attack and defense, not the fields, the properties. There we go. So let's press finish here, and we are done with the creature. And now we can implement those modifiers once again, and it's going to be interesting how those come in. So this time round I am actually going to make a base abstract class. Now in the previous example we didn't make an abstract class because we actually used the base class as a root object, as the definition of a linked list, and this time around we don't have a linked list at all. So we are going to have an abstract class, and it's going to be called creature modifier, just like before, and it's going to also implement iDisposable. And the reason I'm doing this is so that you can add a modifier onto the creature temporarily, and then you can remove it later on. So I'm illustrating the fact that you can in fact implement the removal of particular modifiers. So now what does a modifier have? Well, it has a reference to the game, and it has a reference to the creature that's being affected. And both of these should be protected, by the way, because we are in an abstract class, so they cannot just be private. Let's make them protected here. Now we're going to make a constructor as before, hopefully. Let's try this again. There we go. Here's a constructor. I'm going to once again implement all of these. And then, of course, we're also going to have a method you can actually override in order to handle this particular scenario. So just like in the previous example of handle, we're going to have a handle, but it's non-intrusive. It doesn't affect the creature itself. It only affects the query that's being passed in. So I'm going to make a protected abstract void handle, which takes the sender as well as the query, and that's going to be used as the event handler for the events that we've made up above in the game. Now, in addition, what I'm going to do is I'm going to actually subscribe to those events in the constructor and unsubscribe in the dispose. So in the constructor here, I'm going to say game.queries plus equals handle. So I am subscribing, but I'm subscribing something which is abstract. So the derived classes are expected to actually fill in this gap. And similarly in the dispose, I say game.queries minus equals handle. There we go. So we've got our base class, and now we can inherit from this base class, and we can add those wonderful bonuses. So if I want a double attack modifier, all I have to do is I have to inherit from creature modifier. Let's implement the missing members here. And then, of course, in the handle, what I do is I don't change the creature itself. Instead, I check that this is the right creature. This is the creature that we want to modify. So I say if the query's creature name is equal to the creature.name that I'm applying this to, because remember, a double attack modifier applies to a particular creature which is taken as a constructor argument and which is stored in a protected field here, and that's what we're checking. So we check that the name matches, and we also need to check that we're getting the right thing. So q.what to query is equal to attack, because attack is what we're modifying. So if we want to modify attack, what we do is we take q.value, and hopefully it's public. Let's take a look at, yeah, it's public here. So we take the query value and we multiply it by 2. So q.value multiply equals 2. There we go. Okay, so this is the implementation of the double attack modifier. And similarly, what we can do is we can implement an increase defense modifier, which is a creature modifier. And once again, we perform the typical operation. So this time around, we check that the creature name is equal to the appropriate name, and we check that what's being queried, q.what to query, is in actual fact the defense value. So if somebody wants the defense value, we take q.value and we increase it by 2, for example. So now we are done. Let's take a look at how all of this can be used. So we're going to make a game, new game, like so. And we're also going to make a goblin. So that's going to be a new creature, which is referring to the game. Notice the game has to be passed in as a constructor argument. And typically in the real world, you would use constructor injection from your DI container. Then you specify the name of the creature. Let's have strong goblin. And let's have the values 3 and 3. So this is a stronger goblin. We're going to right line the goblin just to see what we're getting. And then we're going to modify the goblin. And because I implemented iDisposable, we can do a using here. So I can have a double attack modifier passing the game and the goblin. And here what I can do is I can right line the goblin once again. And I can right line the goblin after we've exited from this block. So let's take a look at what we actually get. So before we enter the block, the goblin is 3-3. We enter the block and it becomes a 6-3 because we double the value, and then it is a 3-3 again. And we can combine this with the other attack modifier, or rather the defense modifier. So here I can make a new increased defense modifier, once again passing in the game as well as the goblin. And in here I can once again right line the goblin, and this time around, notice what happens. First of all, we double the attack, so it goes from 3 to 6, and then we increase the defense from 3 to 5, and then both of these expire because they're disposable, so the dispose method calls, and we're back to 3-3. So this is how you can implement chain of responsibility using what's normally called an event broker, because this thing brokers events being sent from one component to another, and it's a kind of a mediator. So we saw two design patterns here, the chain of responsibility as well as the mediator.